Hey guys, so I am here to help you understand how to do a hypothesis test with the full 4 procedures. We are going to go through this step by step. Sorry I can't be there today, but you're going to use your data that we collected on Friday to be able to run through this hypothesis test and understand how the 4-step process goes. So before we start, I'm just going to use an example set of data. It's the same one that I'll post in the answer key so that you can look at it on paper if you want to. So we're going to say that pretend there was 116 in our class data out of 239 total. Your numbers are going to be different than this, so as you run through it, you're going to have to make sure that you are thinking through using your numbers in comparison to mine. The only other piece of information that you need to know before we set up our 4 steps is that the claim is about how well they can actually taste the different colors of Skittles. So we're going to see how good you guys do, but just so you know, I Googled the true proportion that is claimed, and it says that the true proportion, oops, mixing my letters there for you, is 20%. Just so you know. Okay, let's use that and let's move through this. We are looking at choosing the correct information to set up our procedure. So I'm going to use my 4 different colors here and walk us through. For the first part, our procedure is going to be a single sample proportion Z, and it's a test this time. Remember, as we're going through these, you have all of your calculator setups, so we're using a hypothesis test instead of an interval. It's really important to think about that. That significance level, they told us, is 5%, so we don't have to do anything with it. I abbreviate it SL. Remember that that counters the 95%. So we're trying to see if what our sample shows us is significantly different than what was expected. So now, instead of looking at what we're expecting in that middle 95, we're trying to figure out, do we have anything that's unexpected in that outer 5%? Okay, just to help you kind of understand that they're connected. The parameter is going to be the correctly guessed that number of Skittles out of all of them. So let's do our P is the correct guessed Skittles out of all Skittles. In this case, P is going to be 0.2, but we're going to write that in below in a moment, so that's why I wrote it in words there. The statistic is going to be our samples. So for me, I'm going to say that P hat is 116. It's X over N, so it's 116 out of 239. You will have to set up your P hat based on the class data that we gathered on Friday. Okay, so be sure you're using your right numbers there. Mine's just an example. The hypotheses, this is where it's different than a confidence interval, because we actually know what we're trying to test against. So we know that the true proportion is 0.2. So we're going to say that our null hypothesis, that's our initial thought about what's happening, is the probability of 0.2. When we do this one, the null hypothesis will always be an equal sign. It's what we are assuming is true about the population. Then we move on to the alternative hypothesis, and that's what we're countering with. That usually represents the claim that is being stated. So in this case, we're trying to make an argument that you guys are better at tasting the Skittles flavors than what is stated. So we're going to make it a greater than symbol to say that you did better than 20%. And what you need to know is that that alternative is always going to be your inequality. It's never going to have an equal sign. Your options there are either going to be this, less than, or a greater than, or a not equal to, if they don't give you any indicator of whether it's greater or less. Okay, but you're never going to have an equal sign in that alternative hypothesis section. Okay, so we've completed the choosing section, which walks you through the information that to set up all of what we know to start with. Now we're going to move on to checking our appropriate conditions. So, same conditions as when we were doing the confidence intervals. So should be nice and easy for you to remember. We don't have to learn anything new. We are going to check to make sure that we had a random sample. Of n equals 239. I'm just going to put in parentheses that we're assuming this. That's okay. We don't know for a fact, but I didn't specifically go find you guys certain Skittles, so you're good. The next up is making sure our sample size is small enough in comparison to the full population of Skittles. So our sample size was 239. We definitely are going to assume that there are more than 2,390 Skittles in the population. That would be the necessary amount. We're talking all Skittles, so it's covered. Okay, and then we need to make sure our sample size is big enough to, I'm not sure if I said big enough on the last one. That was your small enough in comparison to the population so that we could do non-replacement. This one, we need to make sure our normal model works. So we need to make sure our sample size is large enough. We have n times p needs to be greater than or equal to 10. N times 1 minus p needs to be greater than or equal to 10. In this case, we know p. Remember, in intervals, we were trying to estimate what that value is, but this time around, we know it. They told us it so we can test the claim about the population. So we can actually use our sample size of 239 with the 0.2 to validate that it is, in fact, greater than 10. Okay? So you are just going to need to check both of those with P. And so your sample size is going to be different than mine, but you will use 0.2 and 0.8 to validate it, okay? And then because of that, we know a normal model will be appropriate. Okay, next up, we have finished our conditions section. Again, it should feel just like it did for when we did intervals, just a quick review of it, when we go back to one proportion. And for the calculations, the only difference when we get to calculations is that since we're doing hypothesis tests, we calculate the z-score based on what we know. So I have a nice big space here. Remember that your job is to have a picture, your z-score formula, and then your correct answer. In this case, we're looking for the area under the curve. So we're trying to see if that shaded area fits into that 5%. We're seeing if our sample supports what we were assuming is expected. Okay, so let's talk about the picture first. Remember that you're looking at a normal curve, and we know that this is our center at 0.2, and our value for our p-hat value was 0.49. So we know that's over here. We don't know what it is in terms of z, but in this situation, we're trying to decide if this upper tailed area is significant. So that's what our goal is. We're going to have to find Z using our information from our formula. So remember that Z is the statistic, this is on your formula page, minus the parameter divided by your standard deviation. And if you don't know the standard deviation, that's when you use the standard error. Okay? In this case, we know what P is. So rule of thumb, if you know the population's proportion, use it. We only use P hat in place of it if we don't know it. And since we're doing a hypothesis test and we were told that it was 0.2, we get to use it whenever we can. So our statistic is going to be P hat. Our parameter is going to be P. And we are going to, in fact, use the formula for the standard deviation using the population's values. So when I write it in letters, it looks like that. When I write it with numbers, it is going to be my P hat value minus the population's value divided by the square root of 0.2 times 0.8 over my sample size, 239. When you calculate that, you will get a value for Z of 11.03. Think about what that means. That Z-score is 11 standard deviations from what we were expecting, from the center, the average of our p-hat values for that situation, our normal curve. 11 standard deviations above average. That's a lot. There's pretty much zero area under that curve. Normal curves only go to 3. We're 11 away. Okay, so just to show you how to calculate the area under the curve, to remind you, you're looking at your normal CDF, and then you're going to have to tell it where to go. So if you want to use your Z-score, you can, or you can also use the values in the context of your situation. So in this, we would do our lower value, our upper value, our mean, and our standard deviation. And I'm going to do it in terms of Z-scores, so I don't have to go figure out what my standard deviation is or anything like that. So my lower value is going to be the 11.03. That's Z. My upper value is going to be to infinity, so you're going to have to use a bunch of 9s there. The mean is 0, standard deviation is 1, and we are looking at a p-value. Remember, that's the shaded area under the curve of 0. There is literally nothing there. It probably looks like this on your calculator. Well, I guess it doesn't look like that. Sorry, I wrote 2 times. Remember, scientific notation is that E. So you have to think about this as being 28 decimal places to the left, okay? And remember, on your calculator, it looks like this. So we definitely have 0 for our area, that yellow shaded area under the curve. There's nothing there. If you wanted to run this as a test on your calculator, you can go back to your stats button and choose the test that we are looking for. Remember, it was a 1-prop Z test. And then you'll have to enter the values of the information. So we knew that our initial hypothesis was that it was 0.2 about the population. And then our X value from our sample was 116. That number is going to be different for you. The sample size, whatever yours is, type it in. And then you're going to have to tell it that we're testing if our sample was more than what they stated for the initial hypothesis. So you're going to have to enter it like that. It should run it through if you want to test out your calculator. Otherwise, you could wait till tomorrow and I could go over it with you in class. Okay, our conclusion is going to be a two-step process. So when we make conclusions, we can interpret the probability and we can also make our decision and then write an interpretation of the actual context of the situation. So with that being said, I'm going to write it in two parts. So the first one is going to be me interpreting the actual p-value. And usually they only have you interpret the p-value when you are doing like multiple choice. But just in case, if you want to put it on your paper, it's helpful to understand how to word what you found. So we're going to say that if the true proportion of guessing Skittles correctly is really 0.2, then there is a 0% probability of getting what we saw happen. So if in my case, it's going to be of getting 116 out of 239 purely by random chance. Understanding what that p-value is telling you helps you make your choice. So that's what's coming up next for us. We're going to have to make a decision, and then we are going to have to conclude our hypothesis test in the context of our situation. It's always in context. You guys know that. So to make our decision, we have to think about that p-value. There was a 0% chance of seeing what we saw happen by chance. Therefore, you guys would be amazing at tasting Skittles correctly. It was so unlikely that that would happen by chance that we're convinced you're better than average. Okay, so we're going to say that because 0% is much less than our 5% significance level, because that's what we're comparing it to, what we saw happen was very unlikely to happen by chance. So we are not going to support our null hypothesis. Okay, which means we reject it. So over in our conclusion, we are going to say, so that was our choice. We made a decision to not support the null hypothesis. So we're going to say that at the 5% significance level, this is where we can put it all in context. We have enough evidence that the true proportion of correct Skittle guessing is more than 20%. Go back to your wording and think through what the alternative hypothesis was originally. We make our decision based on the null hypothesis, and then we write our conclusion based on the alternative. We either support or don't support the null, so then our alternative is what we need to say. So since we're not supporting the null, we are supporting the alternative, okay? So hopefully that helps you understand this situation instead of just reading it from my notes page. And please at this point switch modes and start working on either check your understanding if you want more practice or your FRQ for tonight. Remember that you have a Khan Academy that will be posted as well. Okay, good luck guys.